Today we're going to be talking about transformation of quadratic functions. So transformation of functions. So a few sections ago, about a chapter ago, no, more than that. Anyway, we talked about translation of functions and what A did to a function, what the H and K did. So now what we're going to be looking at is we're going to be looking at a specific function. So instead of this f of whatever there, we're going to have our function now as x squared. So what you want to think about, remember h moves left or right. Okay, and it's opposite of what it thinks. So if it's x minus 3, it's going to move 3 to the right. And then k is up and down. Okay, and that's exactly what it seems. A is going to be a vertical stretch or compression. And then the negative, okay, so if A is positive, we open up. If A is negative, our parabola is going to open down. Okay, vertex form of a quadratic. That's exactly what I had on the last slide. Y equals A x minus h quantity squared plus k. And my vertex is going to be at hk. And again, if A is positive, if you are a positive person, you smile. If you are a negative person, you frown. Okay, and parent function key points. Okay, so you have your vertex. Okay, so when I'm looking at y equals x squared, okay, that's the parent function. We have the point 0, 0. We have the point 0, 0. That's my vertex. I don't have, if you look at it, I don't have an h, I don't have a k. And then if I plug in -1 and +1, I'm just going to go up 1. And then if I have -2, +2, I go up 4 from my vertex. So I go over 2, up 4. So just a reminder, that's what our parabola looks like. It's not linear. It has some curve to it. And that little blip there, that's just because my iPad case. This little blip, where's my little pointy thing? Oh, I guess I don't have a pointy thing. I thought I had a pointy thing. Anyway. Okay. So graph that function, state the domain, range, and vertex. Okay, so remember, this 3, okay, that's 3 to the right. It's opposite of what you think. Even though there's a negative sign there, I go 3 to the right. And this is 4 down. So I put my vertex down. So I go 3 to the right, 4 down. Okay. So my vertex is 3, -4. Now, remember, A is 1 in this case. So it's this same counting that you would have here. Just you have a new vertex that you're going off of. You're not going off of 0, 0. You're going 1 left and right of where your vertex is, and 2 left and right of where your vertex is. So I go left and right 1 and up 1. Left and right 2 and up 4. And be careful you're counting correctly. It took me a little minute to get that point down because I was counting over 4 and I knew I was doing something wrong. And remember, your graph has a little bit of a curve to it. Trying to ideally go through those points. I'm writing on an iPad, so it's a little bit more challenging for me. Your domain is always all real numbers. And again, remember my abbreviation for that is this double R, as I call it in my head. I'm going to be using that throughout the rest of the PowerPoint. And your range, okay, so I open up, so your vertex is a minimum, so y is greater than or equal to that vertex point. Now graphing this function. This 4 means I go up 4. There's nothing being added inside that x squared. So technically your h is 0. So my vertex is 0, 4. Now this 1/2. Okay, again, going back. That's going to affect this right here. That's going to affect it. It's going to cut all of these y's, this column, in half. Doesn't affect the x's. It cuts the y's in half. So I would go over left and right 1, but only up 1/2. Left and right 2, but only up 2 because half of 4 is 2. And again, my domain is all real numbers. I'm using my abbreviation. Your range, your vertex is 4. It's a minimum. So y is greater than or equal to 4. Now this next example has all of the translations that I usually like to give you guys. I'm excited about this one. I'm going to use my favorite color, purple. So plus 2, that means left 2. Plus 7, that means up 7. So I go 2 to the right and up 7. I don't know why I wrote a 4 there. There's not even 4 on here. Okay. This 3, that means I open down because my a is negative and my y's get multiplied by 3. So I go left and right 1, but down 3. Left and right 2, but down 4. Down 4 times 3, which is 12. And notice you're symmetrical. So if you get one side, you can just go off this axis of symmetry. Remember, this is your axis of symmetry. I'll draw it in there real light. I don't know why I don't like drawing it in. I just don't like drawing it in. And then that's what your graph looks like. Your vertex is -2, 7. Domain, again, always all real numbers. Your range, since you open down, less than or equal to the y-coordinate of your vertex. Now we can use completing the square to get this into vertex form. Let's write this one in green. So remember your vertex form. Y equals a x minus h squared plus k. So writing this in vertex form, it's a little complicated, but I know we can do it. So set out your y equals x squared minus 2x and put this little 4 on the outside. Remember to complete the square. You do your b term over 2 and square it. Remember your b term is this term right here, what's next to the x. So I add in a 2 divided by 2 squared. I have to subtract that same thing. 2 divided by 2 is 1, squared is 1. It's an equation. It needs to stay equal. That's why I add in here, and I subtract outside. So I have this piece, and then I have plus 3 on the outside. That piece right there is going to factor. What I tell my students is you've rigged the problem. You've made it so this has to factor to x minus 1 squared. So then just for fun, our vertex is a 1, and a 3. Remember, opposite of what it looks like inside there. I'll write the following of this one in vertex form. Now remember, completing the square, you need your coefficient in front of your x to be 1. So what I need to do is I need to factor out a 3. Technically, it's a negative 3. I apologize. From that, I didn't trust myself. I'm factoring out a negative 3 from both this term and that term, the x squared and the x term. So then I'm factoring out a negative 3, so I get a plus 6x. Leave the 10 alone outside. Now I need to add in something. Okay, I need to add in 6 divided by 2 squared. So that's 3 squared, which is 9. I added 9 in the outside. Now I need to subtract the number outside. So what I've really added in is negative 3 times 9. So be careful on that. Okay? So now, where I'm getting that. Let me highlight where I'm getting that. I'll do it in orange. Negative 3 plus a 9. That's really what I've added in. Okay? So I need to subtract that on the outside. And that's why I've tried to make that very clear here. So now we factor. This turns into x plus 3 quantity squared. If you need to do this work, we have a minus a negative 27. Yeah, I'm showing all the steps, because why not? So I have a negative 12. Or I have a 12 minus a negative 27, that turns into a plus 39. Okay, last example. Write the following in vertex form. Okay, we have y equals a x minus h squared plus k. So remember, this is my h, this is my k. So I can plug that in right away. I don't know why I added another parenthesis over here. Minus 3. So I have my vertex in there. This is an x and a y. I'm going to plug those in. My x is a 4 minus a 2. So now we solve for a, because I need to figure out basically this. And since quadratics are not linear, we can't just count out a slope. Quadratics don't really have a slope. They have a different rate of change. And that's a whole calculus thing. We can talk more about that at a different time. But I have a 4 minus a 2, and then I square that, and I get a 4a minus 3. I add 3 to both sides. So now, going off of this, I wish I could copy and paste. I'm sure that there's a way. 1/2 x minus 2 squared minus 3. Okay, and that is your video on quadratics in vertex form.